Okay, so in this section, we're going to be looking at conic sections, and the major conic sections we're going to be looking at are the parabola, the ellipse, the hyperbola, and being able to write them in terms of polar equations and to find the eccentricity. All right, so let's start with the parabola. Now, we've all seen parabolas before, but there's a certain way that a format that the parabola has to be that creates a parabola for us. All right, so let's start with the parabola. Don't know why that green ink. All right, so the reason what we have here in order to be able to determine what a parabola is I'm first going to draw a axis here. And I'm going to draw a point, which is going to be my focus. So this focus point, and that is the point 0, P. So it is P units from the origin. And then I'm going to draw a line that I'm going to call the directrix, and it is also P units from the origin. So here is the directrix. All right, so this line is y is equal to minus P. Negative P. Okay, so now what I want to be able to create is I want to find all the points that have equal distance between. So if I pick, let's say I choose a point right here. So here's X. And so this point right here happens to be X negative P. So this point is X negative P. And this point right here happens to be X0. Okay. So I want to find all the points that happen to be, so we're looking, so the way the parabola, to develop the equation for the parabola, so this is a point on the parabola right here. And that point had, oh, that's wrong. I drew it wrong. It's up too far. I need to bring it down. So this is the point. Okay. And so let's not worry about that point for a minute. All right, so this is the point I'm concerned about. This point right here is the point X, Y. So the parabola consists of all the points whose distance from here to here is the same as the distance from there to here. Now my picture doesn't look quite accurate. It probably should be lower. That's better. Okay, so now if I choose this point here, now it looks more accurate. All right, so those distances are the same. So this is the point XY. So therefore, I want the distance between so every point that's going to be the same distance from X minus P to here will actually be all the points that are going to be on the parabola. And so we're going to call this point the focus. This is F. That's my focus. This point P is my point XY, and I'm going to call this Q. So my focus is the point 0 minus P. The point P, capital P, big P, happens to be XY. And then Q happens to be X, also little p. So now I need the distance from F to P to be equal to the distance from P to Q. All right, so I need the distance formula. So the distance formula is very simple. So the distance from F to P is the square root of, so now I'm going to take X minus 0 squared and add that to Y minus negative P squared. Okay, I don't know why I wrote this as negative P. That should be positive P. It's up in the air. The bottom one is negative P. This one's positive P. Okay. So now Y minus P squared. And then the distance from P to Q is equal to square root of X minus X squared plus Y minus negative P squared, which is going to give me Y plus P squared. And I need these to be equal. So therefore, I'm going to take, for the first one, the square root of X squared plus Y minus P squared has to equal the square root of Y plus P squared. So when I square both sides, I get X squared plus Y squared minus 2YP plus P squared is equal to, on this side, I'm going to get Y squared plus 2YP plus P squared. So now the Y squareds are going to drop out and the P squareds are going to drop out. And so I end up getting X squared is equal to 4YP. And so that gives me the equation of the parabola, that is Y is equal to X squared divided by 4YP, divided by 4P. So that is the equation of a parabola in that form. Okay. So the fact that this is y is equal to x squared, so this parabola opens upward. So it opens up. It has a focus. Equal to 0p and a directrix equal to, which is y is equal to negative p. Okay. All right. Now we can have the same kind of parabola opening downward. Okay. So if we were to flip this upside down, we would have something similar. So we could have something that looks like this, or I could have my directrix could be y is equal to p. And then my focus would be here. And then I'd end up with a parabola that looks like this. And in this case, I would have y is negative x squared over 4p. My focus would be 0, negative p, and my directrix would be y is equal to negative x squared over 4p. Now, similarly, I can do the same thing in the other two directions. All right. So now I can have a focus, which is going to be P0. And my directrix is going to be x is equal to negative p. So now I'm going to have a directrix that looks like this. So now I'm going to have a parabola that's going to open as such. And its equation is going to be x is equal to y squared over 4p. And then I can have a focus there, and I can have a directrix here I like my directrix to be blue. So now my focus is negative P 0. And my directrix is X is equal to P. And my parabola is going to open sideways to the left. And I will get X is negative Y squared over 4P. Okay, so here's an example. Find the focus and directrix of the parabola Y squared is equal to 10x. Okay. So I need to put it in one of these forms. So clearly I'm going to get X is going to be Y squared over 10. So therefore, now that I have it in that form, I know the form that it should be in is X is Y squared over 4P. So that's going to imply for me that 10 has to equal 4P. So P is going to be 10 over 4 or 5/2. Since this is a parabola now opening to the right, okay, so it's an X parabola, so it opens to the right. Then I know that my focus is also on the right. So that's going to be P0. And my directrix is going to be X is equal to negative P, which is negative. So this says my focus then is 5/2, 0. And my directrix is X is equal to negative 5/2. All right. Any questions?
Yeah, I was just about to ask. So, so see how you substituted the 4P for 10? Would it
Yes,
always be 4P?
it's always 4P. So
Okay.
for a parabola, it's always 4P.
Okay,
Okay,
thank
so
you.
it's either going to be this case or it's going to be this case.
This part, this like what you're teaching today is kind of like simple. The other stuff, sometimes I just be a little thrown off. That's why I had to
Okay,
rewatch it.
that's why I said, why you dropped the class? Why you dropped the class? It's not, I'm gonna help you through. I'm helping you through. Okay. All right. You stop acting cray cray. I want this, and I want that. Thank you. It's going to be one of those four. If it's in that form, if one of them squared and the other's not, it's a parabola.
Okay,
And
thank
then you
you.
have to put it in that form, okay? All right, so the next thing is an ellipse. Okay, so for an ellipse, it's still not the one I want. Okay, here's an ellipse. So an ellipse has two foci, and an ellipse has two vertices. Okay. In other words, that's the plural of focus, is foci. All right, so the way we start this thing off is we have the center. And so now I want to find, here are my foci. My foci are at -C, 0, and at +C, 0. And there is a distance between, so now I'm going to choose a point P on the curve. And this P is XY. All right, this focus, this is foci, focus 1 and focus 2. And there is a distance as if I had a string and I tacked the string and stapled it or nailed the string to the different foci. And then I had a point P that could rotate. So now as I rotate P around, the distance here has to stay constant. So then when I get to this point, the distance is here. If I go up to another point up here, oh, that's the wrong one. Okay, I'm keeping the distance between the point those have to stay the same. So as I'm rolling this thing around, I end up with something that looks like this. Because I keep the distance constant. So how does that look as an equation? Okay, so this is what it looks like. So I need the distance between F1 and P plus the distance between F2 and P. Well, right here, I'm going to call this point A and this negative A, and I'm going to call this point B and this negative B. So as you can see, this right, these are now going to be my vertices. So when I stretch it from here, and back, that distance is the same as stretching it here and this distance. So therefore, I need this to equal 2 times that length which is 2a. Okay. So now what's the distance between F1 and P? So that is the square root of x minus negative c, which is x plus c squared, plus y minus 0, so that's y squared. So that's that distance, plus the other distance, which is x minus c squared, plus y squared. And that has to equal 2a. Now, the way you solve this thing, I'm not going to go through all the algebra because this is Calc 3. But the way you solve this is you start off by taking the square root of x plus c squared plus y squared, and you let it equal to 2a minus the square root of x minus c squared plus y squared. And then you square both sides. So when I square both sides, I get x plus c squared plus y squared is going to be 4a squared minus 4a times the square root of x minus c squared plus y squared plus x minus c squared plus y squared. And then you put everything else on the other side and you square it again. Okay. When you do all that algebra, when you get done, you end up with x squared over a squared plus y squared over a squared minus c squared is equal to 1. Okay. So we're going to take and call this thing right here a squared minus c squared. So we're going to let b be the square root of a squared minus c squared. So now we get x squared over a squared plus y squared over b squared is equal to 1. Okay. So that is the equation of your parabola. Your ellipse. Okay. Now, it matters whether or not whichever is bigger, that's going to, so your A is always the bigger value. Okay. So therefore, you always want to make sure that we have two axes. So the one that where A is larger, that is your major axis, and the one where B is smaller is your minor axis. Okay, so the major axis joins minus A to A. So in this particular problem, going from here to here is our major axis. So this is the major axis. Okay. So if I had something like, oh, and the other axis is the minor axis. So this is the major axis. And then the other one is the minor axis. All right, so notice that A is always, in this case, bigger than C. A is always bigger than C. If A is equal to C, or A can't be equal to C, A is always bigger than C. Okay, so you can always find C then by saying that A squared minus C squared is equal to B squared. So therefore, A squared minus B squared is equal to C squared. So C is always the square root of A squared minus B squared. Okay. So here's an example. So I have x squared over 16 plus y squared over 9 is equal to 1. So now let's find all the important things. All right. So the semi-major axis well, we can clearly see that A squared has to be 16. So A is equal to 4. All right. And then our semi-minor axis tells us that B squared is equal to 9. So B is equal to 3. Okay, so we got that much. So now we can find our center, our focus, C, is equal to the square root of A squared minus B squared. So that is the square root of 16 minus 9, which is the square root of 7. So therefore our foci are plus or minus the square root of 7, 0, because they have to be on this axis, the square root of 7, 0. So they're there. And our vertices are the endpoints are plus or minus 4, 0. Okay. And the center of this is 0, 0. But suppose I gave you this. X squared over 9 plus y squared over 16 is equal to 1. So now we see our semi-major axis. Our A squared, again, is still 16. But now here, the major axis was the x-axis. This one is going to be the y-axis. So all the important stuff is going to be on the y-axis, not the x-axis. So the semi-minor axis says b squared has to be 9. So that's going to be the x-axis. Our c, again, is the square root of 7, but our foci have to be on the y-axis. So our foci are 0 plus or minus the square root of 7. They have to be on the y-axis because this thing is going to be bigger in y than it is in x. It's going to look like that. And our vertices are also going to be on the y-axis. So they're going to be 0 plus or minus 4. Okay. Any questions? Are you good?
Yeah, I understand this.
Okay, yeah. All right, one last one, hyperbola. So now notice that with the ellipse, the foci were inside. Okay, so the ellipse, the foci are inside the vertices. The hyperbola, the foci are going to be on the outside of the vertices. Okay. So now with this hyperbola, this time I'm going to draw my vertices. Well, here's my foci. Okay, so this one F2 again is C0, and this one over here F1 is negative C0. And now I'm going to draw a curve as such. So here's my curve. And my vertex is here. So those are my vertices. So notice A is smaller than C now. That's the first thing we can note, that A is smaller than C. All right. So I want all the points on the curve that the distance to this point on the curve. So I want that distance to remain constant. Okay, and how long is that distance? Again, that distance is going to be 2 times A. All right, so if you take this one distance and you subtract the other distance, all right, the constant difference needs to be 2A. The other one, the constant sum was 2A. I want the constant difference to equal 2A. So this is my point P. So the distance from P to F1, from F1 to P, minus the distance from F2 to P, I want that to be plus or minus 2A. So it doesn't matter which way I go. Okay, so if I do the distance from F2 to P minus the distance from F1 to P, just the absolute value of that distance is always 2A. Okay, so again, I'm gonna start it, but I'm not going to finish it because it's just plain algebra. Okay, so the first one is x plus c squared plus y squared minus the square root of x minus c squared plus y squared. And that has to equal plus or minus 2a. So you do the same thing, throw one to the other side, square it, then square it again. And when I'm done, I get x squared over a squared. This time I'm going to get plus y squared, same thing, over a squared minus c squared. Is equal to 1. But now we have to remember the fact that a squared is less than c squared. So a squared minus c squared is negative. So therefore, if we take this and write this as x squared over a squared minus y squared over c squared minus a squared equals 1. Now c squared minus a squared is a positive number, so I can let b be the square root of c squared minus a squared. So now I end up with x squared over a squared minus y squared over b squared is equal to 1. And again, a is bigger than b. Which one is bigger? Well, we get from this relationship that c squared is a squared plus b squared. So I'm trying to think major and minor axis. It's always going to open up to whichever one is first, regardless whether it's bigger or not. So if x is first, it's going to open up in the x direction. If y is first, it's going to open up and down. Okay, so that's one piece of information. Then we can also find what we call asymptotes. So to find the asymptotes, we're going to let x squared over a squared minus y squared over b squared go through the origin. So you get y is equal to plus or minus b over ax. And so that goes back to say there's an asymptote that comes through like this. And another asymptote that comes through like this, which are very helpful in helping you find how to graph this. So let me show you one. And so here's an example. So I have x squared over 4 minus y squared over 9 is equal to 1. Okay. So I know this is going to, so the quick and dirty way to graph it is this. This is the quick and dirty way. All right, so a squared is 4. which says A is 2. So go to 2, 1, 2, 1, 2. So go to 2. And then B squared is 9. So that says B is 3. So go up 3 units and go down 3 units and make a box. Then your asymptotes go directly through the box. So your asymptotes go through like this. So there's your asymptote. Okay, so that's the quick and dirty stuff. Okay, so now what is the focus? So C squared is C is equal to the square root of x squared. I'm sorry, a squared plus b squared. Which is equal to the square root of 13. And the square root of 13 is, let me just get an idea so I can plot this thing. Is roughly 3.6. So therefore I need, whoa. I should have drawn my picture much smaller. Oh, well, 3.6 is way out here. So that's here and there. And so my thing is going to look like this. Yeah. Okay. Now, if it were y squared, it would go the other direction. Okay, so my foci are now still plus or minus the square root of 13, 0. And my vertices are still plus or minus a 0, so plus or minus 2. Okay, that's why that's wrong. I couldn't figure out why this was wrong. That's just where the focus is. That is not where the parabola is. That's where the focus is. The hyperbola, the vertex is here. That's why I was feeling like that was not right. Okay, so now this is the curve. Remember and this is the opposite. The vertices are inside the foci. So that's the way it's supposed to look. Okay, now I'm happy. I wasn't happy a minute ago. I didn't like that curve. I didn't feel like it was right. Now it's right. Because they're supposed to be plus or minus 2, 0, and they are. And some of these can be twisted in different directions. Okay. All right, so here's a cool example. Show that now we can actually do things that shift. Okay, so for example, x minus 2 squared over 9 plus y minus 4 squared over 4. Actually, I don't want that to be 4. Y minus 3 squared. So this is an ellipse, but it's shifted. It has a different center. So this ellipse is x minus h squared over a squared plus y minus k squared over b squared is equal to 1. And so this has center 2, 3. So this ellipse has been moved. So this ellipse looks like this. So go to the point 2, 0, 2, 3. 1, 2, 1, 2, 3. So here's the point 2, 3. I don't think I made this big enough. Okay. And so A is 3. A squared is 9. So A is 3. B squared is 4. So B is 2. So I need to go in the X direction. I need to go over 3 units. So 1, 2, 3, and then 1, 2, 3. So right here, that's my one vertex and my other vertex. And then B is 2, so I need to go up 2 and down 2. And so here is my ellipse. I made that too far. Okay, so that's the ellipse. All right, so if I didn't know how to draw it, so I went to my center, which is 2, 3. And I know that this distance is A. So I had to go over 3 units, and this is minus A. And then up here is B. And down here was negative B. So that allowed me to get to those key places. Okay, so how can I find everything? All right, well, everything just shifts just by a little bit. Okay, so we're going to change this and let's get a new variable. So my new variable will be x tilde. and y tilde. So now I have x tilde over 9 plus y tilde over 4 is equal to 1. Okay, so we still know what C is, right? So this is an ellipse, and so therefore, when we go back to our definition of the ellipse, we know that C, in order to find C, we have to take a squared minus b squared. So C is a squared minus b squared. A squared is 9, b squared is 4, and this is the square root. So C is the square root of 5. So it's somewhere in here. Square root of 5 is like 2.7 or something like that, 2.2 actually. So my C, my foci are like that. Okay, so how does my foci move in respect to what I had before? Well, x star, x tilde is x minus 2. All right. So C tilde becomes square root of 5 minus 2. So I think that should be right. Let me make sure. No, it's not. Remember, C is square root of 5. And so if we had, for this one, the focus would be plus or minus the square root of 5, 0. But that's when it's x tilde. So the foci of x tilde is that. So therefore I get plus or minus the square root of 5 is going to be this C minus 2. So therefore the C for the original problem is going to be 2 plus or minus the square root of 5, 0. So yes, as you can see, this focus is now 2, and we move it plus or minus the square root of 5. So that is correct. All right, so that's how we found. So now we found the focus for the original problem. What are the vertices? Well, the vertices of x tilde over 9 plus y tilde over 4 is equal to 1. Those vertices, well, we're going to use A. They're plus or minus A, 0. So those are plus or minus A is 3, 0. So therefore, the vertices of the new problem, so we still have, so the x tilde is equal to x minus 2. So these are now plus or minus 3 is equal to x minus 2. So therefore, the vertices for the original problem are going to be 2 plus or minus 3, comma 0. So what are they? That's 2 minus 3, so that's minus 1, 0, and 2 plus 3, which is 5, 0. And I think that's what it looks like. Yep, that's what it looks like. Here's minus 1. And then this was 2, and then we added 3 more. So this is 3. So those vertices are in the right place. Okay. Any questions? Are you there?
No.
Okay.
Yeah, I'm still here. Sorry,
Okay.
I forgot I had myself on mute.
Oh, all right. Do you think you understand now and you can get that?
Mm-hmm.
All right.
So,
So,
like I said, today was a lot easier than like most
oh,
days.
absolutely.
This is
And
like algebra.
yep. And then next week, I'm trying to think what we cover next week. Let me see, syllabus. Oh, next week is vector. Next week is easy.
Okay.
Next week is easy. Yep. I wish so the parameterized, see, so let me stop the video.